Hello everyone. Today inshallah we will continue on our previous lecture. I will try to finish some exercises and some problems, and also we'll go through some of the previous problems that appeared in previous exams. Please, I would like you to review the previous lecture. It's already on YouTube. You will have to go through it as fast as possible. Then try to identify the regions from the given sets according to what you are going to see, and then try to answer the questions that already exist on your workbooks and plus those problems. Please try to resolve these problems more than once, trying to use your hand. It's really major. Just to keep writing everything and to keep up with everything in your in those problems and trying to solve as much as possible. I know for this part it contains plenty of definitions, but it's really important. You will have to do it. It's a direct question in your exam, so please try to do it. Thank you. Okay, as I told you today, I have some problems I will have to solve and to go with you. Nothing new, but it is a strengthen on the previous information that we have. Okay, so I will start with this problem number 16 in your workbook, and it's giving you a set which is x and y belongs to R2, where y is less than 4 minus x squared and absolute of x is less than 3. I will need to identify this region in order to answer the rest of the questions, which required first to represent graphically this set is this set, which is called A bounded. Try to justify. Find the interior, the boundary, and the exterior of A. Try to identify it. All of this will play an important role down the road with us. Is A an open set? Is A a closed set, and justify? And also find the limit points of the driven points and the isolated point if they are exist. So the first thing to do is to try to understand the nature of your curves. So the first of them is, as you can see, y is equal to 4 minus x squared. So understanding your curves, it will help you out greatly in order to draw it and to understand what's happening with your curves. So it's a y equal 4 minus x squared, that's the boundary. So all I have to do, this is the y-axis, that's the x-axis. This is an equation of a parabola which is symmetric about y. So I will use the equation of y in order to find the crown if possible, because as you can see I can't find the term in x. So it's really very simple. So if I put x equal to 0, then we will start at 4. And as you can see, the signs of y and x squared, they are already different. So your curve is looking downward. So the curve is simply going to be, this is your quadratic curve, or the shape of the second degree parabola that we are talking about. If you like to identify the points where the curve is going to cut the x-axis, it's also accessible. It's really very simple. All I have to do is to solve this equation with another equation, y is equal to 0. I'm sorry. So, alhamdulillah. Inserting y equal to 0, so we will have 4 minus x squared equal to 0. That's x squared is equal to 4, which leads to x plus or minus 2. That's negative 2, and that's positive 2. That's for the first curve. That's if I have equal sign. But here he is giving you y is less than 4 minus x squared without an equality sign, which means that the boundary of your curve is not with you. So this part is not with me. This is no equality sign exists. And he is searching for the values of y, which is less than 4 minus x squared. So we are interested in the points in the middle. But before I identify it, I will see if there is another functions inserted in this relation or not. And absolute of x is less than 3. So if I want to identify absolute of an x which is less than 3, it means that we will have positive or negative x which is less than 3. That's either x at the, as you can see, less than. So the limit is at 3, so this is 3. So I'm talking about a curve like this or a straight line, x equal to 3, that's x equal to 3, and x equal to negative 3 in a similar manner or on the other direction, as you can see. Extending the wings of your quadratic function, it will go like this. So now I'm talking about the points which is less than positive or negative 3 and also satisfy it is inside the parabola. So now I am talking about the points that exist in this area, which is the intersection of the parabola and also with the extension of the straight lines that you can see of the absolute. So this is actually what's happening in here. That's the points, or that's the region that we are interested in inside the parabola and also within the boundaries of x is equal to 3. I'm sorry, Adam, I had to start because I have training and unfortunately I have to do this lecture with you. I can't delay it. Okay, so this is the part that I'm talking about. So once more, if I want to do this, this is the shape of your parabola exactly. It will come from 4 and then go down. We are interested in y less than 4 minus x squared. So we are interested in the points inside the parabola. In a similar manner, we are talking about absolute of x less than 3, which means x is less than positive 3 and greater than negative 3. So it is the portion in between them. So if this is positive 3 and that's negative 3, that's the portion that we are interested in. I will put them together because I have and in here. And so this is the region that I'm interested in. If you remark, that's the region that I am interested in, which is inside the parabola and also bounded by the straight lines. I hope it is clear for you. Okay, this is very good. Now I identify the area that we are interested in, which is A. As you can see, now it's clear for us. I will start answering each question presented graphically. Is A bounded set? Do you think that A, which is this period, is it, or this region, is it bounded? No. It is bounded from the sides by positive 3 and negative 3. It's bounded from the above by the curve nature by itself. But from down, it's open. Okay? So, no, it is not bounded. So, this is the set as I told you. And if you want to identify these 2 points, we can find them. We can find the intersection of these 2 points simply by solving the 2 equations together. So I can solve, in order to find this point, all I have to do is to make a small substitution. I have y equal 4 minus x squared, replace x by 3 or negative 3. So you will have y equal to 4 minus 9. So y will come up to negative over 5. If I inserted negative 5 over here, then I will have negative x squared equal to negative 1, which means that I will be able, that's if I inserted y equal to negative of 5, so negative x squared is gonna be, negative x squared will equal to negative 9, which means this point and that point will happen at 3 and at negative 3. These for the intersection if you want to identify. Here we go, that's the points that I told you. Now, the boundaries, no, it's not bounded because it's restricted horizontally and from above, but from down it's not restricted, so it is unbounded. He also asked you about the interior. The interior of A, it's all the region inside the parabola and bounded by positive 3 and negative 3. So, interior, all inequalities are strict, thus every point of A has a small open disk that can be already inserted, so the internal of A is equal to A. Remark, the internal points are the points inside the set without the points on the boundary. Are you with me, Adam? And since the boundaries are open, the boundaries, there is no equality in the boundaries, as you can see. So it is not bounded because it's open from down, and also the interior equal the A directly, so both of them equal to each other. Okay, the boundary occurs, or the boundary exists around the parabola till the point at x positive 3 and negative 5, and the point negative 3 and negative 5, then it will be bounded by positive or negative 3, and that's what's written in here. This is the bounded or the boundary area exactly. Okay, the exterior of A, the exterior of this point or the exterior of this set, it's all the points outside the parabola. So it is y greater than 4 minus x squared. And for absolute of x greater than 3, which means the sides. Everything in R2, so it's R2 except A closure. Why I inserted A with bar? Because every point outside the internal of A plus the boundary, and that's the closure, okay? So it is R squared except A dash, that's the exterior of A. Is A open set? A is an open set because it is defined by strict inequalities, let them the value of 4 minus x squared and less than 3, and the A is not closed because boundary points are not included, so it's not a closed set. If I want to identify the other question, so I've done with C, now for D, find the limit points. All the limit points or all the points of the interior are considered limit points, and also all the points on the boundary is limit points. We don't have isolated points, so mainly the driven points, the limit point, it's the driven point, they are both the same. It's exactly like the closure of A, and the closure, it's less than or equal, and this is absolute of x less than or equal to 3. No isolated points, I don't have any points within my region that you can find the intersection between them and your set, and just only the result will be that point only. There is no neighborhood, so there is no isolated point because every point has infinitely many near points around it. In a similar manner, this is also another question which is really very nice. He wants you to represent or to graphically put the set y greater than or equal to x squared minus 2x, and also y is less than or equal to 4 minus x squared. And this is really very simple. All I have to do is to once more try to graph these two curves together, but I have just one trick I wanna show you, which is the case when you are dealing, okay, it is the case when you are dealing with a quadratic function or a parabola, okay, while you have an x with it, so you will have to do a completing square. Look, the general case for a quadratic, if I have y minus d equal k in x minus e to the power of 2, now I will be able, that's the normal form, that's the general form. Using it will help you to graph any type of parabolas, okay, with vertices different than the origin or the general ones. So if I look to this equation, I will go the vertex of your parabola, it's gonna be E and D. So all I have to do is to go for X at E and for the Y-axis at D, as you can see. This is the points E and D. That's the vertex. Then I will look to K. If it is positive, then your curve is looking upward. If it was negative, it will be looking downward. So if I look to those curves, I have the first of them, which is y greater than or equal to, as you can see, x squared minus a 2 over x. I want to draw it. So let's first try to put it on the normal form. Let's leave the inequality issue. Let's talk about the boundary, the equation by itself. So it's a y equal to, I will try to make completing square. In order to do a completing square on this term, I will consider a bracket to the power of 2. From x squared, I will take x. This number, I will divide it on 2, and the rest, I will put it inside the bracket. So negative 2 divided by 2 is going to be negative 1. Then, once more, the first square is x squared. The first, second times 2 is going to be negative 2x. The last square is positive 1. So I will have to add negative 1. And so the equation will be, or the general form will be, y plus 1 equal to x minus 1 to the power of what? To the power of 2. If you look to this equation and to that normal form, now I have the vertex. The vertex is really very simple, which here starts at positive 1, and for the y coordinates is going to be negative 1. That's the vertex. And as you can see, the sign here is positive. So now, if I want to draw this quadratic form, all I have to do is to go at x equal to positive 1, y equal to negative of a 1. That's the vertex. And then it will arise up like this. I know you have a question, why did I draw and cut the x-axis at these points? I need these points. It's really very simple. What I have to do is to take this equation, once more, leave the inequality at the time being, which is y equal to x squared negative over 2x, and to put it equal to 0. Why to put it equal to 0? Because actually the x-axis equation is y equal to 0. So all I have to do is to insert y equal to 0. Now take x as a common. You will have x times x minus 2 equal to 0. So your curve will cut the x-axis at x equal to 2 and the x equal to 0. Okay, now I've done perfectly with the graph of this quadratic function. The other quadratic function is y equal to 4 minus x squared. Okay? But before going further, I have an inequality saying that I am interested in the points that's greater than or equal. So it is talking about all the points inside your parabola, including the boundary. So it is the boundary and above. Then I have the other equation, which is y less than or equal, y less than or equal 4 minus x squared, which by the idea can be put in this form, which is y minus 4 equal the negative of x minus 0 to the power of 2. And now the vertex, it's really obvious. The vertex is gonna be x at 0 and y at 4. So I will go for x at 0 and y equal to 4. This is y equal to 4. And remark the negative sign, which means your parabola will be open downward. So now it will go downward in this manner. And I'm interested in the area or the region in between of them. So this is how to go step by step through your set. So once more, that's the main curve, okay, of y greater than or equal x squared minus 2x, greater than, I'm talking about the points inside, and that's for the curve 4, and I'm talking about the points inside it. Now I'm going to put them all together. So this is the region that I am interested in. This is 0 and 2, and if I want to identify when those curves are going to cut each other, all I have to do is to solve the two equations together. So all I have to do is to substitute from one into the other. So simply, I will have x squared minus 2x equal to 4 minus x squared. And then I will solve this equation, which is really very simple. All I have to do is to get the negative x to the other side, so it's a 2x squared minus 2 over x minus 4 equal to 0. That's x squared, a negative of an x, am I right? Minus 2 equal to 0, which can be easily factorized to be x and x, 2 and 1 equals 0. This is going to be a negative, that's positive. So x is equal to 2 or x equal to negative 1. And yes, it makes sense. This is at negative 1 and this is at 2. Exactly right. I have all the points. I am in control on the region that I'm interested in. So this is how to go through it or through all of it, as you can see. Oh geez, okay, just in a second. Because if you try to erase as quickly as possible, you will be able to erase it. But if you leave it, it's going to be difficult to erase or clean the screen. Okay? Okay, very good. Now, that's B, the point above the parabola, as I told you, and the blue 4 minus x squared. So, present graphically the set. Is B bounded set? Is it bounded? Yep, it's bounded. You have boundaries all over the place. So this region is bounded from above by 4 minus x squared, and bounded from blue by the curve is x squared minus 2x. That's actually what's written here. The lower parabola is going to be on this form, which is when a negative 1 opens upward, and the lower parabola is going to be, as I told you, the upper parabola is 4 minus x squared. To find the intersection points, I will solve them together. So set B consists of all points between the two parabolas, that's between negative 1 and 2, and yes, as I told you, it is bounded set, it's restricted between negative 1 and 2. Y lies between the two finite elements between the area in the x-axis or the y-axis. Interior points satisfy strict inequality, so the interior is x squared minus 2x less than y, okay? And y is less than 4 minus x squared. I can write them, remark at them, I can write x squared minus 2x less than y, which is exactly like this one. And y is less than 4 minus x squared. Or combine them together, it's really up to you. This is why I wanted you to see this. Also remark, Mr. Muhammad, that I don't have the inequalities here because I'm talking about the interior points. Are you with me? I'm talking about the interior points. So the interior points doesn't include the boundary. But, so this is why the internal of B or the internal points of B doesn't equal to B. B is not equal to internal of B. Are you with me? Oh, but B by itself, it is equal to the closure of your set because it includes the interior points and the boundary points. ماشي شباب؟ طبعا هنا هو boundary. It's gonna be x equal x squared minus 2x running a union y equal to 4 minus x squared running from the both sides. So he's describing the boundary to be the part of this function from -1 up to 2, and the part of the upper function, union the part of upper function. This is how we are talking about the boundary. If you add the boundary to the interior points, then you will have directly your closure. So B is closed, okay, it's not open because the boundary points are included, which means the closure is equal to your set, okay? Once more, okay, this is very good. We are done with this guy. Also, there is no isolated point, if you remark. And for the limit points, it's all the points inside the region are limit points, okay? Look to this problem also. One of the beautiful problems, it came into fall semester 24 and 25. And he is giving you y, remark, y is less than or equal x minus 1 to the power of 2, which is an equation of Danny, y equal x minus 1 to the power of 2, it's an equation of also a parabola, صح? A parabola with a vertex at 1 and y equal to 0. Okay? And for the straight line, y equal to x minus 2. And for x is greater than 0, so I'm talking about the right-hand side. I can see from Mr. Muhammad eyes that he's lost. I will do this one also for you, and the next one will be in a quick, but I will try also to graph it for you or to draw it for you in order to make it very easy for you down the road, or you will be able to do it simply. So now I have, as I told you, I have y which is equal to, okay, x minus 1 to the power of 2. It's an inequality, but I'm not talking about the region at the time. I'm trying to find the boundary or the curve, how to graph it. So it's a y equal to x minus 1 to the power of 2, which once more is an equation of a, this is the x, that's the y. The vertex is gonna be at x equal to y, to 1, I'm sorry, and 0. So this is your curve open upward, as you can see. So that's the first curve. The second curve, it is simply y equal x minus 2. This is y equal x minus 2, which is an equation of a straight line. Am I right? So if I put x equal to 0, it will drop to -2. If I put y equal to 0, then x will equal to 2. And then I will try to connect them together. Here we go. That's the line that we are talking about. And of course, they are going to cut each other. That's the line, and that's the curve. So they will cut each other, as you can see. And x, remark, and the x is greater than or equal to 0, which means I'm interested in the x part, positive part. So once more reading the inequalities, I need the points where y is less than x minus 1, which means all the points below or beneath this parabola. I will need the points which is greater than x minus 2, I mean the above. So I'm talking about this region. That's the region that I'm interested in. Wait. And y doesn't equal to -1. How to put it? So I will come at y equal to -1 and y doesn't equal to -1. So it's like this part is open. You understand what I'm saying?
Yes.
Okay, that's my region. That's my region. So once more, Mr. Muhammad, that's the shape, as I told you. This is the curve that we are interested in at 1 and going up. This is the line from -2 and the +2 and to the right. So this is the whole area, as you can see. This is the whole area that we are interested in. If I want to have the answers. I've already sketched A, I've done with it. Determine the interior of A, so XY, the interior points would be without the boundaries. So it's simply y less than, instead of less than or equal, it's less than x minus 1, and greater than y of x and, minus 2, and the x is greater than 0, and also y doesn't equal to equal. That's the interior. If you remark, the interior doesn't contain the boundary. So all the boundaries are not with you. Okay. طيب, get the boundary. The boundary is the portions, the parts that I'm going to talk about. Try to signify them. You don't have to follow this train. Just understand the boundary. The boundary, it is like this. Those parts, that's the part of the boundary that I will be interested in. And then that's the part of the boundary that I'm interested in. And that's the part of the boundary that I'm interested in. Are you with me, Adam? Okay, those are the boundaries. See how I'm going to describe them. أنا بدأت أصدق خلي بالك. Y equal to x minus 1 to the power of 2, which is the part of the parabola. صح؟ بس أنا عايز أقول ال part of the parabola هو إيه؟ x and يعني معاه. x must be greater than or equal to 0. يبقى أنا بتكلم على البارت بتاع البارابولا اللي فيه x is greater than or equal to 0. يعني الحتة يعني الجزء اللي هنا. اللي هنا كله بما فيه ده. فاهم؟ شلت الجزء الناجح. خلي بالك and انا رحت فين؟ and اهو and x is greater than or equal to 0. So I'm talking about this part. Or y equal to x minus 2 and x is greater than or equal to 0. يبقى البارت of the straight line in this side where x is greater than same way like. بص اوكي يبقى or x is greater فين احنا رحنا فين بس y and x is greater than or equal to 0. Or x is equal to 0, so, and I'm talking about this guy, x is equal to 0, from y negative 2 up to y equal to positive 1. يبقى I'm talking about this portion. شايف بلف side by side. بلف side by side. Okay? Or y equal to negative 1 and x is greater than or equal to 0, less than or equal to 1 in order to vanish this part and to find the boundary that I'm talking about. Okay? That's the boundary. طيب A dash is the driven point. What's the driven point? The accumulation point, the limit points. So the limit points actually includes all the interior or the closure, okay, of your area with y greater than x minus 1 and y is greater than or equal to x and x is greater than or equal to 0, so I'm talking about the whole area or whole of A. Okay, the point 0 and 1. Let's look to the point 0 and 1. X equal to 0, x equal to 0, and y is equal to 1. هو عايز ايه؟ بيقول is it a limit point؟ يعني 0 1 دي is a limit point of A. Why? Justify. طبعا point 0A is a limit point of A because ليه تعتبر limit point؟ لان لو جيت عند البوينت اللي بالك مستر محمد عند البوينت 0 1 دي وعملت سيركل ماشي with a tiny radius هيبقى في points تانية inside this circle belongs to the set okay other than the point by itself. ده اللي written عندك. 0A is a limit point of A because it is a limit of a sequence of elements of A distinct from one of 0. So if I took the limit of 0 and 1 minus 1 over A, it will be 0. I can also describe it, okay, as follows, that if I can write if we draw a bubble, which means an open ball. So an open ball with 0.01, okay, centered at the point 0 and 1, okay. This point intersection, the area is not equal to 5. يعني لما اجيب الانترسكشن اذا كان دي اسمها A يبقى الاوبن بوينت او الاوبن بول عند 0 1 with a tiny radius intersection A, it's not gonna be 5, it's gonna be okay It's not going to be an empty set. As you can see, I still have those points that exist inside this area. So this is why it's an point. Justify why half and negative half is an interior of A. Because I can, at half and the negative half, draw a circle, complete circle, okay, which is completely gonna be contained inside the interior. Once more, half and negative half is an interior point of A because there exists an open ball centered at 2 and negative half. If I took 0.1, then that's the equation of the open ball, less than 0.01, because I take 0.1 to the power of 2, okay, which such that B is a subset from A. I can write it in both ways. Also, that's another problem with the same exact situation and with the same exact description. I believe I've already sent you all of these slides yesterday. Am I right? Did I send it or not sent? Please check. Okay. I will have y is greater than or equal to absolute of x. Okay. And y minus 1 to the power of 2, x squared plus y minus 1 to the power of 2 greater than or equal to 1. This equation is an equation of a circle. Okay, that's an equation of a circle. With center at x equal to 0 and y is equal to 1. So that's the circle. That's the circle. Intersection, the absolute of x. That's the absolute of x. So now I have also inequalities with equal sign. معايا Mr. Muhammad? لذلك هتلاحظ ان الباوندري coming here and also on the part of the circle, then about this one. If this region closed, if this bounded region, no, it's not bounded. Why it's not bounded? It's bounded from the sides, but from the above, it's not bounded. اوكي طبعا هتلاقي في الاجابات كل مره الامور بتتحسن اكتر. يعني هنا الانتيريور over A is y greater than absolute x and x squared plus y minus 1 is greater than 1. I'm talking about all the points inside the region without the boundaries. The boundaries is going to be absolute x and the x squared y minus 1 is greater than or equal to 1, or x squared y minus 1 squared and y is greater than or equal to x. I'm describing exactly the boundary. كلمة or